Welcome, everyone. Today, we're doing something a little different. We are going to look at your organization's IT spend. But instead of getting totally lost in the technical weeds, which, let's face it, is easy to do, we're doing a bottom-up architectural briefing using a city metaphor. Because really, good hardware, it's the invisible foundation of your entire business operation. And understanding how it all connects is absolutely crucial for making those big budget and strategy decisions. So, taking a quick look at our agenda, we're going to systematically build our understanding here. We'll start from the physical on-ramps, where your employees actually enter the network, and work our way all the way up to those massive enterprise software servers that act as the headquarters of your digital city. All right, let's kick things off with connecting your network devices, the on-ramp. Just like a physical city, right, every journey in your network needs a starting point. Every device needs an on-ramp to access the corporate digital highway. And that on-ramp, it's called the Network Interface Card, or NIC. Basically, it's a printed circuit board sitting directly inside your employees' computers, and it provides the essential interface to your network. It operates at what we call Layer 1, literally the physical layer, where it prepares, sends, and controls data. And here's the crucial part. Every single NIC carries a unique code called a MAC address. Think of this as a unique, completely unchangeable license plate for every single vehicle entering your corporate highway. Now, if you crack open a machine, here is what these enterprise cards actually look like. Notice those tiny lights on the back? Those are link and speed LEDs. A solid green light immediately tells your IT team, hey, we have a valid network connection, while a blinking light means data is actively transmitting. It's a super simple visual diagnostic tool, but man, it saves literally hours of troubleshooting when an employee's machine suddenly goes offline. Moving on to local traffic, let's talk about hubs versus switches. So once your employees' devices are actually on the network, we need local traffic managers inside the office building to route all that data. This brings us to a really critical hardware distinction. Older networks relied heavily on hubs. To use our city metaphor, a hub is kind of like a person standing right in the middle of your office with a giant megaphone shouting every piece of data to everyone everywhere. It just takes data from one port and copies it to all the other connected devices. It has no idea how to read those unique MAC license plates we just talked about, and it has zero decision-making power. You can imagine the severe network inefficiencies that causes. And this is exactly why modern businesses invest their IT budgets in switches instead. A switch acts as a highly secure, direct courier. It adds vital intelligence to your data management. Instead of shouting to the entire room, it reads the destination MAC address of the data frame and forwards it only to the specific correct port. You can see how this brilliantly illustrates the real-world impact of your hardware choices. Hubs pose a massive security gap, right? Because confidential data is just being broadcasted to every machine on the hub. Plus, they cause frequent data collisions because everyone is sharing the exact same bandwidth. Switches, on the other hand, operate at Layer 2. They fix this by providing dedicated bandwidth to each end device and segmenting the network to prevent those massive data collisions. Honestly, upgrading from hubs to switches is usually the quickest way to speed up a sluggish corporate network. Now, for departments where data security is absolutely critical, think finance or HR, your IT team is likely going to deploy Layer 3 switches. These are specialized, incredibly powerful devices. They don't just do MAC address switching, they actually add intelligent IP routing right inside your local network. By maintaining a dedicated routing table, they keep sensitive local subnets tightly controlled and highly efficient. It's a real game changer for internal security. So, the big question here is, how do we securely transition from our highly controlled local office network out into the chaotic global internet? That brings us to external connections and the vital role of the router. That major transition happens at the router. If switches are the local couriers inside your office building, routers are the massive highway interchanges connecting your local networks to the outside world. They operate at Layer 3 of the network model, and their main job is to evaluate IP addresses and decide the absolute best, fastest path for your data to travel across different networks. But they are also your primary border guards. Routers handle critical inter-network communication and manage traffic security using firewalls and access control lists. Essentially, they filter out malicious external traffic before it ever even has a chance to hit your local switches. Now, when you're reviewing hardware purchases with your networking team, you're definitely going to encounter the classic wired versus wireless debate. Wireless routers are everywhere because obviously they offer vital mobility for phones and laptops, but they are prone to physical interference from walls and require strict WPA2 or WPA3 security protocols to prevent hacking. So for your core enterprise backbone, wired connections absolutely remain the gold standard benchmark for pure speed, minimal interference, and maximum security. And the actual physical roads connecting all this hardware matter immensely too. This is your transmission media. Coaxial cables, for instance, require physical terminators at the ends to absorb signals and stop data from just bouncing back and forth. Then you have fiber optic networks, the absolute superhighways, which use electromagnetic energy and pulses of light for incredibly rapid transfer rates. We're talking up to 300,000 kilometers per second. And of course, wireless networks transmit via invisible radio frequencies, typically on those 2.4, 5, or 6 gigahertz bands you're probably familiar with. Next up, let's look at the traffic rules for avoiding collisions. Looking under the hood at the rules of the road, you quickly realize that without strict rules, these digital highways would instantly turn into gridlock traffic jams. When multiple machines try to talk at the exact same time on a shared network, bam, a collision occurs. To fix this, systems use something called carrier sense. If a collision is detected, the machine immediately interrupts the transmission and sends out an interference signal, which is known as a jam signal. This basically tells all other devices, hey, hold on. Then every device waits a random back-off time before trying again. And because that wait time is random for each device, the probability of them colliding a second time is remarkably low. Pretty clever, right? Let's look at another brilliant traffic management system that's historically been used in networking, the token ring. Instead of a chaotic highway where everyone just tries to jump in whenever, a token ring acts like a highly structured, exceptionally fault-tolerant digital roundabout. So let's see how this cycle works step by step. Imagine a single empty vessel, the free token, just circulating the network. To send a message, a machine has to actually capture this free token. It then writes its data and the recipient's address right into it. This data packet is then passed from machine to machine around the ring. When the recipient finds its address, it reads the data and sends an acknowledgement. Finally, the original sender receives that acknowledgement and releases the free, empty token back onto the ring for the next user. It's an incredibly orderly way to guarantee data delivery without any collisions. Finally, let's talk about powering your operations with network servers. All of this infrastructure we've talked about, the NICs, the switches, the routers, the fiber optic cables, it all leads to the ultimate destination buildings of our corporate city, your network servers. These are the immensely powerful machines that handle your core business operations. You have file servers storing user data with elaborate security systems. You have database servers, which are basically muscular machines dedicated solely to managing complex data requests from client computers. Web servers handle your outward-facing web traffic, and communication servers manage the flow of your corporate email, remote access, and essential firewalls. But, perhaps the most critical line item in your IT budget is the domain server. This is the ultimate gatekeeper of your digital city. It's responsible for authenticating every single computer on the network and authorizing every individual user. It controls exactly who has access to which resources within your logical domain. Without a robust domain server, your local network is essentially unguarded, and we definitely don't want that. As we wrap up this explainer today, it's clear that understanding the difference between a hub, a switch, and a router, well, it isn't just IT trivia. This stuff directly dictates your company's operational capacity, your cybersecurity posture, and your overall efficiency. So I'll leave you with this final thought to discuss with your technical leads at your next budget review. When you look at the flow of data across your organization today, is your current network infrastructure a superhighway empowering your business to scale, or is it secretly a bottleneck holding you back?